Hoopy, this is going to be a private session between you and the two of our professors. So we're really glad to have you. For anybody else listening to this recording afterwards, welcome. This is our secret university session during HackSecret. We'll be covering the Richie Rich secret box. So the Richie Rich secret box is a mini project that any developer new to the ecosystem can come and learn some DeFi concepts on how to hide private information using viewing keys and permits. And so we'll get straight into it in a moment here with our professor DDT, who's been in the ecosystem for quite a while now. All right, DDT, next slide. All right. But before we begin, wanted to quickly highlight what Secret University is all about. We are an educational platform created for developers on Secret Network, trying to make learning how to create privacy preserving smart contracts and applications a little bit easier and a little bit more accessible. So our platform is at scrt.university. And we have launched a number of key material for all the students that are willing to learn. We have secret ways, which are led courses that walk you through specific concepts, such as secret smart contracts. We have a number of different courses coming up, so definitely check us out. We are coming out with some materials covering the front end and the secret toolkit storage and launching your dApp on the platform. And then next slide, DDT. And then we have secret boxes. So secret boxes are those mini games, mini projects that you can create, such as Secret Counter. And the one we'll be covering today is called Richie Rich. These are already hosted on Gitpod environment. So you don't need to do any initial setup. You can go directly to our platform to start looking at the code and seeing how different things are configured. So yeah, today we're going to be covering the Richie Rich box. This is actually a sneak peek before our module launches on the platform. So today, DDT will be walking us through how to execute contracts, setting viewing keys and permits, all under the idea that you are a Richie Rich person about to see if you have won a lottery. So you want to take us away, DDT?
Right. So I'm going to share the code now. Yeah, just forget that for a while. We'll get to that later. So let me know if there's any issue to the screen, but you should be seeing some code right now. So this is our second session. Previously, we talked about the counter box, which was a more basic tutorial going through essentially the template contract that we have, where the functionality is minimal, but it shows you how to create very basic contract. Today, our second session, we're going to talk about more the privacy aspect. So specifically how you work with viewing keys and query permits. And we'll talk about it from the perspective of a contract developer, as well as an app developer doing the front end interfacing with this. So viewing keys and permits, I won't go into much detail on what they are. I assume you already at least know what they are. You would hear about this very early on in Secret Network. It's a very core part of what allows us to design private dApps, private smart contracts, and so on. Maybe we'll start with what exactly do we mean when we say that Secret Network is private? As you might already know, the native token Secret is actually not private. If you transfer Secret from one account to another, it's as transparent as any chain. You would see, first you see your balance, you see the amount that's being transferred from which account to which account. So at that base layer, actually, there's nothing really private. So when we say that Secret Network is private, we're actually talking more at a smart contract level. So what that means specifically is the messages that we send to smart contracts, as well as the response from the smart contracts or any messages sent by smart contracts to others. These are all encrypted. And secondly, the storage is private as well. So smart contracts have their own storage space, and by private, we mean that all that's encrypted as well. So with these two things, we are able to design private dApps. So privacy is actually can be implemented at a smart contract level. And maybe just to give a quick example, so Secret token may seem from a user perspective like it's something at a base layer, but really it's actually a smart contract that allows you to wrap a secret token into secret. From a smart contract perspective, all it's doing is taking some native secret and then minting some secret tokens. So it's all actually done at a smart contract level. And all these things means that when you are designing a smart contract, if you're coming from a Ethereum or any other transparent chains, you need to think about privacy as well as a whole design primitive. It needs to be correct, i.e. security mean funds cannot be stolen and so on, but also that privacy is not compromised. And a very core part of that is how you design the queries. So there are two types of queries in a smart contract, in a secret contract. One is public queries or normal queries, and the other are authenticated queries. And both of these are slightly different than in a transparent chain. The reason being, starting with public queries, if you don't have an entry point, if you don't have a query that allows you to view something, you actually just cannot view it. No one will be able to see what's in the contract storage. And authenticated queries means only certain addresses or certain people can actually view certain things. So for example, balances. If you are familiar with Secret, you require a viewing key to view your own balance. So let's jump into what this box does. If this thing loads, that'll be great, but looks like it's not. So never mind. What we'll do is we'll start with viewing keys. Rich is a contract that, just to give a bit of an overview on what this contract is doing, it allows, say, multiple users, in this case, an arbitrary number, to work out who's richer. So, for example, if you've heard of the millionaire problem, there are, say, Alice and Bob both want to know, both have a substantial amount of wealth, and they want to know who's richer, but without revealing their actual net worth. And there are several ways to do this. If you Google it, if you read it out, you'll see there are several ways this can be achieved. But on Secret Network, it's quite straightforward from a contextual perspective. All you do is each party submits their net worth, and then the contract just compares them and tells through a query who's the richer one. So that is not so much the focus of this session. We'll focus more on the query aspect. So how do we design the query such that only authenticated parties are able to view the result of who's richer? So starting with viewing keys, what we have here are two types of queries. If you look at this enum here, we have all info and am I richest. So what it means is, after submitting the net worth, they can query this contract, and all info returns two things. It tells you whether you're the richest, and it reminds you what your net worth that you submitted is. And this can be useful if you want someone else to see the result. So let's say if there's a third party who wants to know who's richest, you might also want to reveal the net worth in addition to whether you're richest, or you may not just want to reveal the result. So there are two ways you can query this contract. And in this case, we are making both of them authenticated queries. So there are no public queries in this contract. But the first way to do it is to have viewing keys. So I'm going to just reset this contract to the start point, which you would see if you are working with the box. So if you follow the link, you would see the starting point. This is already completed. So just give me 1 second. Okay. So you may have seen the solution. You saw that there was some code here, So for viewing keys, it used to be something which devs needed to implement from scratch. But thankfully now we have a secret toolkit packages for a package actually for viewing keys and one for permits. So it's made coding much simpler. It's mostly boilerplate with some variation. If you notice, the different scripts actually do it differently because at that time it wasn't so standardized yet. But this is one of the simpler ways to do it and probably reflects very much on how Secret does it. So typically the first thing you do is for the query message, we've defined these two things here. As I said, all info and MI reaches. These two both need viewing keys. So we normally, if you're familiar with Rust, it's normally a good idea to implement trait or associated functions on enums or structs rather than writing separate functions. So we implement on query message something you can name it anything, but for Secret, I'm just using the same name here, get validation params. And what this does is if you look at the contract later, it gives us, basically we want it to return two things, the address of the sender, so the address as well as a string, which will be the key, the viewing key. So let's complete the code here first. If you're following along, feel free to code hopefully in the box as well if it's working already. So here, as I said, first is, well, actually we want it to be a result. So standard result is ADDR and a string, which would be the key. And then here, this is sort of boilerplate. So when you don't need to think about exactly what it's doing from scratch each time if you are designing your own smart contracts. You can pretty much copy what's here. So seeing something here. I'm just using the mouse a bit more than normal because probably easier for you to follow along if I do that. So here you need so all info. So what we're doing is saying, let's look at what the query message is. And if it's all info, which is one of the variants of this enum, typically the first thing you do is to check whether the address is valid. So there's something in API called address validate, which you can do like so. So what it does is it checks whether the address is a valid address, and if it's not, it'll throw an error. And then once that is done, you return the address, which comes from that line above, and the key. So that's typically how you do it. Actually, the reason why it's returning an error is because you actually need to add something here. Seems to be something. There should be some errors. That's the problem with live demonstrations. But what this is supposed to do is it's an associated function, so it's a method, essentially. If you're familiar with Rust, you know what this is. So it's a check object, which basically means that you don't need the API type directly, but just any type that implements the API trait will work. So that helps with flexibility. So that's why there's this DYN thing here, dynamic, basically. And then that allows us to access the API, which API is actually something from dependency. So dapps has something called API that has some useful functions such as validating, humanizing addresses, and so on. So if we go back there, so what we need to do now is to add the other variant. So this is something called mi-regist. In here, we do the exact same thing. So we can just copy this, paste it here, and then here, essentially also return address. I'll try to work out what's going on there, but oh yeah, of course, being silly. So what we've got now is the associated function here, which allows us to do an important step later we'll see in the contract file, where we basically return, let's check whether the address is valid and then return the address and the key. So that's the first step typically. Now let's move to the contract. So here's where we're going to use what we just wrote there. So when we query, typically what will happen in a contract that has both public and viewing key queries is you first handle the public queries up here. You just do it the normal way as you would have seen in our previous session or in our pathway. But for viewing key queries, you need to do this extra step here. So typically what you do is to first get the address. So again, something like this. So API, again, I probably missed it somewhere up there. No, sorry, what am I doing? Sorry, ignore that. Sorry, what? Just curious. Yeah, what we need to do here, sorry, is to use that. Sorry, I just had a bit of a confusion there. We need to use what we just defined in the previous step. So we want, so let me just, where was that? Yeah. So we want to use this thing called get validation params, which returns address and string. So I somehow just rewrote that whole thing. And the way we do that is to say let address, let's call it, say, validated key. So this is where we use it. And here is where we are able to just check the address and return these two things. And then typically what you do is the next step is to do something like that. So viewing key is from the toolkit right now. So it makes things a lot easier. So if you follow that, you'll see that it has several traits and several useful functions you can use. So one of that is check. So what that does is it looks in the storage. So viewing keys, when it was created, we'll get to that later. It's the execute function. It actually saves the viewing keys in a storage space with this binary, and in a prefix storage, you will see here. So that's all handled by the package. And when you check, all it's doing is to check that the address that's sent as part of the message matches the viewing key that's also sent part of the message. And from the dev perspective, you just need to write this line of code, which makes things a lot easier than it used to be. So it accepts. I think that should work. Yeah, so now you have a result. This thing, if you follow the code and view the source code here, you see that it checks that the viewing key matches the account, and it returns a result, an OK result down here, if the key matches the expected key and an error otherwise. So what that means is we want to let them through if the result is okay and return an error if it's not okay. So we match result is okay. So we do something like that. So query all info is a function that's already defined somewhere in this contract here. So basically it's saying, is the result okay, go ahead. And I think this needs to be addressed.
Are they matching the viewing keys together, or are they matching against a single viewing key?
What do you mean by single viewing key, sir?
Like, do they have to match a predefined one viewing key that is set, or is it just that if the two viewing keys from both sides of the parties match each other, then it continues?
So yeah, let's get to that now. So initially you'll need to create a viewing key. So as you probably know, you need to first have an execute function that creates a viewing key, and that is something which is logged on chain. So when that is done, what happens is, so here we have set viewing key. So when that is done, what it's doing is, in the storage space within the package, it stores the address that created. So we stores the address that sent that message and the associated viewing key. So for example, if Alice sends this message called set viewing key and a viewing key that's say ABC, in the storage space, it would have her address and the associated viewing key, which is ABC. And what we just wrote just now basically checks that the address matches that specific viewing key. So when you query, let's go back to message. So when you make a viewing key query, you'll need to specify the address as well as the key. So what we've done just now basically check that it matches. So you can just go up here. So this line here basically checks that this address and this viewing key match. Does that make sense?
Awesome. Yeah, that makes a lot of sense. So basically, you set it initially in the execute function up top, and then later on with the query, you're checking against the one you set previously within the storage. Right?
Yeah, exactly.
Awesome. Thanks. That
And
helps a lot.
the reason why that's required for queries is because you might ask, say for execute functions, you can actually just check directly that whoever's sending the message is the correct person, is an authenticated person. So let's say if Alice has some secret and she has some balance of it and wants to query it, if you could say, why not just look at the sender address and that it is, Alice's address. And if it's not, return an error. If it is, then return the balance. The reason that cannot be done for queries is that there's no message info here. So if you look at execute, there is something called message info. So there's the dependencies, environment, message info, and message. But for queries, that message info is missing. And message info has the sender here. So basically what we're saying is for queries, we cannot reliably, we cannot query who sent the message in a secure way. And that's why in the message itself here, we need to send the address that we're interested in and the key. Does that make sense?
Yeah, that makes sense.
So essentially, a view key is like a username and password. So we need to supply the username and the view key is a password. Whereas in an execute message, you can look at your username, which is your public address, directly and just say, well, yes, you are the user that's allowed to do this. But in a viewing key for a query, if you're using viewing keys, think about it as a username and password. So you will need to supply both. And hence, don't use ABC as your viewing key because that'll be easy to guess. So you think of it as a password. Yeah. So for viewing keys, that's pretty much what you need to do. You need to do the same thing down here. And the code will be pretty much the same as what's up here, except you'll change this to whichever function you want for this query. So I will pause for another 15 seconds or so before we move on to permit in case there are any questions.
Yeah, I do have a question. On the message.rs, you did the error check with denoted by the question mark, but yet you did it again on the contracts.rs under the declaration for the let statement. Is that something normal to do, or is it? Yeah.
So to have two question marks here. So you mean this one here?
Yes, and the one in the message.rs. You already asked for you already did an error check. So is that normal to do another error check when you're just passing on the values from there?
Yeah, so that's required actually, because to have this question mark here as well as this question mark here, because basically starting from this one, the reason is the API is defined, address validate rather, is return a result which needs to be handled. So if it returns an OK value, what happens? If it returns an error value, what happens? So a question mark, because this function itself returns a standard result, so you can just use the question mark, which means if it returns an error, it will be handled by this function itself. So that's a Rust thing.
Okay.
And because this itself returns a standard result, it means that in the contract file here, you need to handle this error somehow. It's basically handling the error. What happens if there's an error? Because this could return an error, right? And
right. I thought that if there was an error, it's going to either abort or give another else statement or something, right? But I get it. Thank you.
Yeah, you could do that. So you could have a custom error, but a question mark basically just says let let the function that is in handle the error. So basically, the error handling would kind of bubble up, and it'll be handled ultimately by this function here, the entry point function. So it saves you from having to define what the error message is or what the error handling is at every step. It basically just says, let this top function do it.
All right, thank you. That was actually very clear.
Okay, great. So let's move on to the other way to have authenticated queries. So viewing permits is something which was introduced a little later. So recall what we said, that viewing keys are basically like having a username and password. You first need to have an on-chain execute function to create that viewing key, which is like the password. And then when you query, you use the address and the viewing key, like the username and password. There's another way to have authenticated queries, which is query permits. And that makes use of digital signatures. So I'll just very briefly talk through what a digital signature is. So I lifted this from a Medium article. I've not read the article, but at least this flowchart is correct. So digital signature basically allows someone receiving a message to check that the message is indeed sent by who is supposed to be sent by, and that it's not being changed by someone in the middle. So, for example, if Alice is sending a message to Bob here saying, I send you 1 Bitcoin, which is what's in here, Bob, or rather the blockchain protocol, actually in this case, can check that it was Alice that sent that message and it wasn't manipulated by someone in the middle. And the way it's done is normally the file is first hashed into, so it's first hashed, say by SHA-256 something. And then with the private key, you can create a digital signature, which is really just a bytecode that can only be created by the private key. So as long as Alice has the private key and no one else has it, this cannot be forged by anyone. And then she would send this data file, in this case in plain text, along with that digital signature. And whoever needs to verify, like Bob, or in this case, also the blockchain protocol itself, it can see the file in plain text, but it wants to know that it's authentic and that's not being manipulated. With the digital signatures, you can use a public key to get this hash from the digital signature using the public key. So public key is viewable by anyone, so you know that this public key is associated with Alice, who has that private key, so you know it's from her. And if these two hash match, then you know that this file has not been manipulated. So this technique is actually used for query permits. What's done is actually this file here says allow whoever with this permit to view my balance for this contract. So when you perform a query, if you send this digital signature along with it, the contract would check that it's authentic, it's not being manipulated. And then if the file, this data file here just says, yes, you can view the balance, and you will let it through. So the advantage here is you don't need an on-chain transaction first to create a key. You can actually generate this digital signature completely off-chain. So it saves, from a user perspective, it's more convenient. And there's some other advantages. One of the disadvantages is more computationally heavy. So if there's a massive amount of query permits, it could slow the chain down, but that needs to be quite extreme. So let's jump into the code and see how that's done. Before that, I should just pause for a few seconds in case there are any questions. Okay. So like in most cases, we typically start with message RS, which is in the previous, as with the previous session, we talked about why that's a good idea. So query permit would normally have its own variant. So what we do is normally to add something here and to just follow the convention in six, it's called with permit. And here you can define what queries are allowed with permit. So let's just say in this case, we want both of these two things here to be also available using query permits. So the way that will be done is to first define what the fields are. So you will need a permit here. And we'll talk about this a bit more. But let me just so this first line here is basically saying when you make a query with a query permit, you first need to supply the permit, obviously, as well as the query message. So this thing here is basically defining what the custom permissions are. So if you look at the permit package, if you don't have this really rich permissions part here, it would just use the standard permissions. And you can see what those are if you follow this. If you read the source code here, the standard permissions are based on SNP 20, and that's allowance, balance, and history. And owner is used by SNP 721 and SNP 1155. But in this case, we want these things don't make sense, so we want to customize it. And that's done simply by providing the generic type here. And so that needs to be defined, and that's down here. So for rich permissions, we want two types. So we want to allow the query to either view all info or mi-riches. So you can see here already that one of the advantages of query permit is it actually allows more granular permissions than viewing keys. So previously, the way we did viewing keys is if someone has the viewing key, they can view either all info or mi-riches. And if they use a permit, we can actually specify which one the permit holder is able to view. So that's one advantage. So here we have something also on the second line called query with permit. So here's where we define the message structure. So it's an enum as always with messages. So here I think we'll also just again have the two things here, mi-riches and all info. And in this case, there are no arguments, because if you recall, for viewing keys, we needed to supply the address and the key. But if you remember how digital signatures work, the permit itself would actually implicitly have the public key in it, as well as there's no need for this key because it's a permit. It's a digital signature itself. So if you look at the structure here, it has the signature contains public key of whoever signed it, as well as the signature. So effectively, if you provide that permit, then there isn't anything else you need to provide. So it's just an empty variant. And same for mi-riches, it's just empty. So now you notice that what we had here previously, the match arms, is now missing this third variant. So we just need to fill that in. So with permit, I think in this case, we just have dot and then say something like, probably want to handle it in a better way, but we can just use panic here. This query It's not recall yet. So what I've done there is to say, this shouldn't really happen. Imagine if you have public queries and you use this get validation params associated function. And if it's not one of the variants that it should be related to, i.e. a viewing key query, it should return an error. So in this case, if, let's say in the contract file, if you recall here, we had this message get validation params. If the message is of this type, which with permit variant, basically it's going to return this error because it doesn't make sense to get a viewing key from a permit query. So that's what this is doing. So that pretty much completes what to be done in message RS if you're going to implement permit queries. So let's go to the contract. Again, you'll notice that, if this is complete, you'll notice that there'll be an error here as well, because you need to handle what happens if it's the cert variant, which we just defined. So before I start writing code here, again, if you have any questions, feel free to ask now. All right. So as I said, there'll be an error here, which helps you. If we had completed this code, obviously now we have an error here as well because we didn't do this, but you will get one here if you had completed that. And it's just helping you because you do have to basically handle what happens if it's this variant. And typically what you do is you will have another function called something like permit queries, which we've actually defined already. That we do something like this. Sorry. So it's just saying for every permit query, just call that function. And that function is this thing here. So here's where you need to then handle the different permissions depending on what the person who in the query. The query would have different permissions, and this needs to be handled basically in this function. So again, quite boilerplate code. Typically, you'll first do something like that. Use the secret toolkit permit package, and it has something called validate. I recall, yeah. And what that does is basically does all the steps you recall here. Does all this stuff here. So with the permit, with the digital signature and the associated message, it will check that it's correct, that it's authentic. So you don't need to understand all the steps, thankfully. So this just does it all for you. And then, this needs to be changed, obviously, to typically you have this actually. So one of the things that query permits allow us to do, the package allows us to do, is to revoke permits. And what that means is, for example, you may have created, so Alice may have created a permit to be used by Bob, and then a few days later, she doesn't want her balance to be viewable anymore, or maybe that permit had been leaked and it's not public. So you can revoke permit. Because remember, with viewing keys, you create viewing keys actively. For permit queries, it's all done off chain. So permits can be just an unlimited amount of permits can be created off chain. So you may want to revoke some to say, no, this is not usable. So that's one of the things that you need to actually do here, where it checks whether or not this permit that's being used has been revoked. So that's what this is doing. And then, yeah, this one needs to be. So this thing out here, we've just got the contract address from the environment here, so that needs to be changed. And this thing typically just still done. So this is, as I said, pretty much boilerplate code now. Because of the package, you can almost copy and paste this in your contract if you want to implement this. And then if this passes, then the permit is valid. So then you need to handle what happens if it's valid. And that's typically just done somewhat the normal way. So we have query with permit plus all info.
Is this where you would be able to add granularity with different permits?
Yeah. So this first line here is typically where you check that the permission is indeed what it is. So you have permit. Yeah. So there's something again called check permissions here. And if you follow, you see that this returns a Boolean, whether or not the permission matches. And what if I fill this in, you'll see to answer your question. I say it's, yeah, this. So what this is doing is to say, if the permission is not all info, and if you recall, this is a enum that we define here with our custom permissions, which is all info versus MI riches. And the standard, the default, if had we not done this, would be the sleep 20 or sleep 721 or 1165 permissions, which are like balance and history and so on. So this line here checks that it is indeed all info, because if you're querying all info, we want to make sure that it has the all info permission. So basically we're saying here, yeah, if it's not correct, what you do is return an error. So here we just make it simple, use a generic error. Just say, sorry, or something. That might not work because it needs to be formatted potentially. No, that's fine. And then now we say, let's see. Yeah, I'll look at the exact brackets later. But basically, this says if it's not the correct permission, don't go ahead. And then if it is, if it is, then go ahead, which will be here. So query all info. Apparently that should. Yeah, this thing here probably can't do this. Yeah, because you need to handle all the others as well. So you need to fill in the other variants, what happens if it's MI reaches and so on. So we're going to have errors here now because we're just writing part of the code. But the point is, you should be having, this first of all, that shouldn't box the match arm. So it should be outside actually. And here you need to also handle what happens if it's MI reaches and so on. So basically, this will be the code if you complete this bit here for how you handle permit queries. So as you can see, this function here is actually the same as what we had defined earlier. Query all info is the same function as what we use for viewing keys. So the only difference with permit queries is we need to do this step here to check that it's the correct permission. And we need to check this thing here as well, that it's not revoked. So that's pretty much the way you do it. I'll stop again for a few seconds in case there are any questions.
No, that was great, PDT. I do have one question. So if I wanted to add the granularity, say if I'm a winner, I would be able to see that I am the winner, but also see the amount of the total that won. But if I'm the loser, I'm not able to do that. Would that be able to be coded in?
So that actually works with all info, because the way we've defined all info is it returns a Boolean, whether or not you're the richest, and the net worth that you submitted. So if you're the winner, what you see is true and your net worth. And if you're not the winner, you'll see false and you'll still see the net worth. So effectively, it achieves that. Does that make sense?
Yes. Thank you.
So what we don't allow in this contract is if you lose, to view the winner's net worth, because that kind of fails the whole purpose of the contract.
Gotcha. Perfect.
So this box is going to go up soon. In fact, if you follow the link, you already see all the code done with the solutions as well. The only thing is it's not finalized. And some bits require some cleanup, and the tutorial write-up itself hasn't been put up. So you can still follow along, look at the solutions in tutorial solutions, and you can actually see what it should look like when it's done. So feel free to already play with it. But as I said, this is the sneak peek, so you won't see the write-up and instructions on exactly what to do. But that will come soon. So I think we've run out of time. I don't know whether Fuzzy, if you would like to just wrap up.
Yeah. So thank you everyone who joined in. I noticed a few people joining in and out that we haven't got to say hello to. If you do have any questions about this counter when it goes live, you can post it in the SU General Discord channel. And all the repositories that are available as secret boxes will be on Secret.university. So definitely check out the platform. We also have a number of different bounties that are already live, from posted by both Secret Labs as well as the community as well. So definitely check them out. Check out the platform. Didn't mean to shield Secret University, but it is a resource that you can all use. We created it for the purpose of educating you guys how to do that. So we would love to see your participation. And if you ever do finish a secret box, definitely drop some feedback. We would love to hear your thoughts. But yeah, thank you so much for this session. If you haven't had already checked out the secret counter box, definitely do so. This is the Richie Rich box where we learned how to set viewing keys and permits, and then look forward to other secret boxes where that will be doing other things. Thank you guys.